Okay, welcome everyone. We'll get this session started. Today I want to talk about why asynchronous Drupal is a big deal. But before we dive into it, while the last few people get in, I want to remind everyone about all the contribution opportunities this week. There's going to be contribution all day today in the hall next to the exhibit hall. And of course, there's more contribution opportunities tomorrow. If you've never contributed, there's the first-time contributor workshop tomorrow. There's going to be mentored contribution throughout if you have any questions. And of course, if you're an experienced contributor, then there's going to be a lot of people there contributing. And also in the session today, there will be plenty of open tickets to still work on. So if they catch your interest, then find me tomorrow and let's see what we can do. So a little bit about me. My name is Alexander Varwijk. I'm a technical architect at OpenSocial. We build online community platforms. One of the things I enjoy in my free time is to travel around. So I'm also really happy to be here in Barcelona this week and have some time next week to explore the city. I'm a maintainer of the Realtime SEO module and the config modify module, and a co-maintainer together with Klausi of the GraphQL module. You can find the slides for today's talk on my website, and after the session, I'll also upload them with speaker notes and make sure they're findable in the app. Now that you know a little bit about me, I would like to know a little bit about the people that I have with me in the room today. First of all, if you're a developer or site builder, anyone who builds things with Drupal, raise your hand. So for you, this session today is important because what I'm going to present is going to give you new opportunities to build with Drupal, also change a little bit, hopefully, how you think about the things you built in Drupal. And if you're maybe an agency owner, decision maker, or other manager, great. So for you, this is interesting because the things I'm talking about today are going to give you new opportunities for the things you'll be building with Drupal. So right now, we're very web focused, and we already have a lot of great modules in our ecosystem, and I think we can change that a little bit beyond the web. So first of all, let's define what is asynchronous. And the easiest definition is to say that it's not synchronous, but that still might not really help you if you don't really know what synchronous is. So let's look at that with an example. For this example, I'm going to use our Umami demo profile. And Umami is a food magazine. And if we look at this web page, then we can identify different elements that are shown. And these are all independent of each other. So first of all, we have the logo. And this is some configuration in Drupal. And if you're building your own site, you know that you can swap this out. So we need to look up what logo we have. Of course, we have the menu. This is yet more configuration that's stored in the database to decide which pages you can go to from here. There's the main recipes block, which is a single bit of data with some different representations for the first recipe, but we can also load this all at once. And finally, there's the promotion for this month's physical issue, which is, again, a bit of content that changes. And let's take a look at how this is loaded when we look at the page. So the first thing that's important is we get the request. And if we look at how Drupal works now, then we have these individual elements that we need to load for the page. So we start with getting the site name from the database. And once we have the site name, we continue first with the menu, wait for that to be loaded. Then we do the recipes, finally the news. And when that's all done, we can send the response. So synchronously, we need to do this one after the other. If we contrast this instead to asynchronous, then as soon as the request comes in, we can start loading each of these independent bits of data from the database immediately. So we tell the database we want to get this data, and the database will come back to us to say, okay, here's your data. The important part is that we need to introduce a little bit of an extra step to assemble all this information together because they may not all be done at the same time. Once we have all the information and we've assembled it, we can send back the response. The difference in timing might not immediately be obvious from this representation. So we can use a waterfall diagram that developers might know from profiling web pages to display the events that happen in sequence from top to bottom against the time that it takes for the request to complete. So if we look again at this synchronous example, you see that we really go step by step to load the individual blocks of data, and we really need to wait until we can send that response. If we contrast that with the asynchronous way of loading data, then you can see that once we know what we need for the request, we can start loading everything at once. And the only thing that's important is that we need to wait for the thing that takes the longest to load to be done, so we can have our assemble step, which is the little yellow line, and then we can send our response. If we overlay these two ways of fetching data, then we can already see that the asynchronous method of fetching this data is a lot faster. So I know there's a lot of caching that we can do, especially if we have these pages that are the same for every user, but it's also important to think about the initial page render, and maybe you have a lot of customization on a per user level. That's when those kind of things break down, and this becomes really important. So we can see that by kicking off independent piece of data for data loading, we can already get a great performance improvement. So this sounds really nice, but how do we get there? The first thing is to note that one of the things that really enabled this was the introduction of Fiber in PHP 8.1. One of the issues that you have when you start building asynchronous application is a problem that's known as the what color is my function program. Because when we write applications that are synchronous, we call functions that immediately return a value. But when we write asynchronous applications, we need to keep track of whether that value is already there. And if you start doing that for large applications, you usually need to change this in a lot of places to keep track of the state. What Fibers instead gave us is a way to write code as if it's synchronous, while being able to keep track of the state outside of this. So this gives us an opportunity as Drupal community to introduce async code without having to rewrite all of the modules. This has already been implemented by Catch and some other great contributors in BigPipe and the renderers. You can catch the slides afterwards where all the issue numbers are clickable. There is also issues that are work in progress for the cache pre-warming and one of the more complex parts of the database. And we can take a little bit of a look at how we might change our application to work with Fibers. So the first thing that we need to do is we get the requests, and then we need to kick off the Fibers for the individual parts. Here I only show the recipes and the news. And the important part is that at a high level, so this might be in Drupal core, we split up this work and organize our Fibers. And we need to have a little bit of a loop there to keep track of when they're done and continue our application and do some scheduling. First of all, that loop will hand off to the recipes, which might have its own loop. And what the recipes block then does is start up a loop, start up its Fibers, wait for them all to be done, and hand back control to the outer loop. News does the same thing of creating its own internal Fiber loop, handing it off to individual Fibers, which do the data loading, and then handing back to the request. Now, one of the problems that we have here is that you see that we actually have 3 loops on this page. So this is the scheduling for the data fetching that we still need to do. Even though the code may still look synchronously, we still have to do some coordination. One of the problems that we see is we do this in a lot of different places, and we have to be very mindful that if we're still waiting for data in one of these loops, we hand back control to the loop that's above it. Because otherwise, while we might be doing some of the work in parallel, we're not doing all of the work in parallel. And this is actually one of the issues we ran into while working on BigPipe, where we saw that the individual tasks for BigPipe were being done in parallel, but we were not actually doing anything while BigPipe was itself waiting for data. So thankfully, there is a solution to this, because there's been some smart people who have already thought about this, and that is the introduction of the event loop. And rather than making many of these small loops ourselves and making sure that we give back control to our parent Fiber, essentially, and need to keep track of that in every place, we introduce into the application a single loop onto which we register the small tasks that we want to do. And with Drupal core, we could invent our own loop. But because we always want to have one per application, this is an important one to not create a Drupalism. because you want to be able to pull in external libraries that might be trying to schedule asynchronous tasks without having to make them compatible with Drupal. So this is where we're working on introducing Revolt into Drupal core. Revolt is a collaboration between the AMPHP and React PHP packages. These are two large asynchronous libraries that offer loads of packages for doing asynchronous work. And they also realize that if they want the PHP asynchronous ecosystem to be compatible across the board, they needed to solve this together to have a single event loop that everything is compatible with. The event loop itself is actually built and maintained by one of the authors of the Fibers RFC, who introduced it into PHP as a language feature. So we can be reasonably confident that they know what they're doing. And it's important to note that this mostly provides the low-level primitives. So you may not interact with them directly, but you might instead pull one of the libraries from these ecosystems to do the tasks within your application. But the important part is that by Drupal adopting the Revolt event loop, those libraries will just work for you. One of the things that the library does is it delegates all of the I/O and keeping track of all the connections and when they're done to native PHP extensions, of which there are about 4. And it'll automatically choose for you the one that is the most responsive. If you don't have any of these extensions available, even though they are pretty common, it'll fall back to a PHP implementation. So it should work regardless of where you run your Drupal application. And you really only need to worry about making sure that there's an extension when you get to about 10,000 of concurrent connections within your application. So I think as a community, we're not yet there. So Revolt is on track to land in Drupal core. There's an issue open that's currently in the reviewed and tested by community. It's mostly waiting for some of the other issues where we're migrating both the work for BigPipe and the renderer that was done to the Revolt event loop, and also to adopt the Revolt event loop within the cache pre-warming system. So if we look back again at this delegation from request to the recipes loading and the news, then we can now see that we have one loop, and each of the blocks schedules its tasks onto that loop and gets the control back when data is available while keeping the processing power available for other tasks. So with this bit of work, I think we can already introduce quite some cool performance improvements for Drupal for web requests. But I think there's more that we can do as a community. So let's take a look at what it might look like if we take Drupal beyond web pages. Because one of the things I often say when I talk with people about Drupal is that Drupal is like the Legos of the web, because we have all these amazing modules and I can just take them and put them together and build whatever I might need at the moment. And we see with initiatives like recipes, that's gonna be even easier, where you just get your box of Legos, run the recipes, and off you go. But what I would like to do is instead not think about Drupal as only for web pages, but think about Drupal as Legos for connected applications. You might ask, what do I mean with connected applications? So for this, I've provided 2 examples and tried to relate them to some of the modules that are already in the ecosystem. There's a bit more work that we'll need to do to be able to actually build this and use this. But for some of those tasks, issues already exist, and I'll show them at the end. So one example is a newsletter that aggregates content from different sources. And one of the important features for this is that we want to make sure that we only deliver the newsletter to the time that the user prefers. Because one user might want it during their breakfast in Barcelona, and another user might want it during their lunch break in China. And it's important that we deliver that at the right time, because that has the best open rate chance for the newsletter. Additionally, we want to make sure that we filter the content based on the user's interest so they get something that is relevant for them. We could pick a commercial service for this, so we could look at something like HubSpot, or maybe cobble something together with Zapier and MailChimp. But those are services where the monthly cost starts at 400 euros a month, and even within the Drupal ecosystem, there's already a lot of modules that can get this done for us. So here's a little bit of practice if you're going to tonight's trivia night. Anyone know what the modules are? Just shout it out if you know. Otherwise, feeds, yes. Symphony Mailer, yes. Of course, yes. And the final one, I think you all use it. Haven't heard it yet. How do I? Yes, search API. So from left to right, feeds, search API, Symfony mailer, and events condition actions. And to solve the problem of this aggregated newsletter, one of the things we could do is make a long-running application which continuously pulls in data through feeds from our external sources, indexes it into search API. We could use some kind of time-based event in the event condition action module and configure it to run through these rules of searching with search API, and finally create the action of searching, of sending the email with Symfony mailer. And of course, with the hot topic right now, we could add the OpenAI module that's already in Drupal to either do aggregation or summarizing for us. So all these Lego blocks are already there. We just need a slightly new way to connect them. We could already get there with a cron-based approach where we run this every so often, but that starts to break down when you get to large user numbers, which means that these days you're likely still reaching for different tools if you need to solve these kinds of problems. The second example is a real-time chat. This is actually something I implemented at OpenSocial a few years ago and actually had to build around Drupal rather than with Drupal, which was not great. So some of the requirements for this application are that it should deliver messages directly to users without requiring them to do anything. So we don't want them to have to refresh the page. It should support diverse enterprise levels authentication mechanisms because we want to make sure that our application is secure. Should have rich media support for images, videos, those kind of things. It should support one-on-one chats, but also group chats. And finally, we want different level of flexible permissions because we see that customers want to use these group chats in different manners. You might want to have everyone be able to invite users, but you also might want the user management controlled by 1 or 2 people, or maybe even use it as an announcement channel where only a select set of people can post messages. So second try for trivia night, maybe a few more obscure modules. Anyone want to take a stab? Group, yes. Yes. There's one in here that's not a module. Simple SAML, yes. Yes. So from left to right again, simple SAML, OpenID Connect, GraphQL, group, and then the final one is actually an alternate logo for React. That is an Easter egg on the React side. So technically not a module, but great for UI. So there's no real nice flow here. But what is important to know is that if you look at these kind of chat applications and you would want to use this as a SaaS service, then if you need features like simple SAML or OpenID Connect, those are enterprise features that you're usually going to pay a lot of money for. But they already exist in the Drupal ecosystem as a module that you can just install. One of the things that GraphQL supports, which is interesting to me as a GraphQL module maintainer, is subscriptions. Subscriptions are a feature where a GraphQL client could have a persistent connection, and the GraphQL server could send messages when it gets new data. Building this around Drupal was actually a lot of work, where I had to make a separate application that kept open all of the connections, and then got a push message from Drupal whenever there was new data to transform a GraphQL query into a subscription message. You can hear the problem. One of the things we can do when we have these connected applications and we have a long running Drupal applications that can keep open the connection themselves is we can use all of the business logic that we already have in Drupal. So all of the entity access API, all of the data loading, and immediately push it to these subscriptions. Of course, the group module is there with a great permission management system to do the member management and access controls for our chats. And as we've seen yesterday, Drupal is rapidly adopting React, which you can use for the UI to make sure that it's all interactive and accessible. So I said that there's a few additional challenges for connected applications. One is that especially for these long-running applications, asynchronous database connections are a must. Because if you have 100 chat clients or even thousands of chat clients, then you don't want your entire application to wait when you're loading a single message from the database. You need to be able to load thousands of messages from the database at the same time. So there's 2 issues open. I think these are the hardest parts of really unlocking the power of async Drupal, because Drupal's database layer is very complex. But there are some other challenges as well. For example, Drupal code and Drupal contrib code currently assumes that it's really only dealing with a single request at a time. So you might use the memory cache to cache entities, but if you start scaling your chat application, for example, you may have multiple copies of your chat application. And if they then keep entity data in memory, then they'll quickly run out of sync when you start editing that or sending in new data. So we'll have to figure out how we can handle that better. We also still see that developers write services which themselves keep global state, which works fine if you have a request and you throw this state away after every request. But when you have long-running applications, that's quickly going to run into issues and conflicts. And like I mentioned, Drupal itself is also very request-oriented, with keeping data that might be related to the current request also all over the place. But it would be really nice if we could have Drupal without any requests. We see if we look, for example, at Drush as a tool, that it currently fakes a request to make sure that it can run Drupal code and execute data loading. But it would be nice if that can happen with Drupal out of the box without a request, or even with multiple requests. So in summary, I've gone a bit quickly, but your help is needed. There's these issues open to really unlock this new way of working with Drupal. It is quite a big challenge, but I think it is worth it. And I think we can focus first on those issues that immediately unlock performance improvements for web requests, and then focus on the bigger issues that really allow us to build these new kinds of applications. So first, adopt the refold event loop, migrate BigPipe and the renderer onto it, migrate the pre-cache or the cache pre-warm onto it. Then we solve the problem of async database, and that's already gonna massively change how we handle web requests. But then we still have those other issues for which there's no issues in the queue yet, of making sure we can do multiple requests or even no requests and other async opportunities. But I truly think that this will unlock new and powerful ways of building with Drupal. Thank you. We have quite some time for questions, either through the app or if you would please to the microphone for the recording.
Yeah, hi. It's been a couple of years since the last time I checked the Drupal org issue about the async Drupal. And at that time, the problem was that it was actually Symfony who had problems go into an async flow.
Mm-hmm.
Has something changed on that field, and we just need to adapt Drupal, or it's still undergoing work on Symfony?
I'm not entirely sure which part. So I think there's a few different approaches to this. I think what you might be referring to specifically is the runtime. And I think there was an issue for trying to change out the runtime for something like FrankenPHP. So I think within the Symfony runtime at the moment, we can already get to those things like the web requests and the data loading for the individual requests. Where the Symfony runtime might be important is when we actually want to solve this challenge of running an application without a request, or keeping a single application running and having it handle many web requests. But I think a lot of these things we can already do without running into that problem yet. Thank you. Anyone else? Yeah, if you could to the microphone. Yes, please.
Thanks for this wonderful presentation. It was really useful. I'm quite familiar with React PHP. We have done a similar implementation for a heavy running CRM API where we had trouble with dealing with concurrent API requests with delays of 40 to 60 seconds. We are doing a similar talk, a sponsored talk this afternoon as well. Just my question around here is, you have mentioned about Revolt PHP. So I'm not sure whether it's an additional layer on top of React PHP, or would that be like a combination of React PHP and AM PHP? How we are looking at the roadmap for Drupal?
So React PHP and MPHP in their previous versions both contained their own event loop. So when you would use that as a library, you would schedule tasks within that library, and it would take care of putting that on its event loop. But one of the challenges this brings is you could not mix those libraries. So you had to choose whether you really wanted to use React PHP or whether you want to use MPHP. What they've done with Revolt is said like, hey, this is actually a problem because they need to choose and they cannot mix and match. So they took the event loop part of the application, which is really at the base of both of those libraries, and rebuild it to be Revolt as an event loop, which uses fibers. And then they've updated, so MPHP in the latest version actually has a requirement on Revolt PHP itself, and it doesn't ship its own event loop anymore. And the React PHP library has an additional library from the Revolt organization that you can use to switch in the Revolt event loop into your React PHP application. So it's really at the bottom layer that you build on top.
I see, that makes sense. And with React PHP, we had to use the socket server mechanism where we had to dedicate a particular port where we can direct the client application request via socket server to the HTTP server as well. So do we see a similar mechanism with Revolt as well when it comes into play for Drupal, whether there will be some kind of a socket server mechanism where we can direct the event loop to run through that, or will that be still through HTTP and with the same kind of service?
Yeah, so it depends a little bit on what application you're building. So if you're staying with the traditional Drupal application model of having one request handled at a time, then you would really only use it for async tasks. I think what you're more talking about is having a single application that would be handling multiple of those requests. And in that case, indeed, you would use such a socket implementation that can work with the event loop. And the event loop libraries that are underneath that, or the PHP fallback implementation, would take care of accepting those connections and handing them off to the connection handler that you have in your application.
I see. Okay, this is really exciting. Thanks for that. And I'm really looking forward to contribute more on those issues.
Awesome.
Yeah,
Thank
we'll
you.
have a chat somewhere. Thanks.
Hi, thank you for the presentation. One question regarding BigPipe, because I thought that BigPipe processes those individual blocks after the initial request already in parallel, because there are like multiple web requests by nature. Though maybe I'm wrong, but where, or could you describe where where do you expect the performance improvement?
So I would have to dive back into the BigPipe code specifically, but what it does at the end of the request is for all the placeholders that are there, it goes off and fetches the data. And I think you're right that it parallelizes that with sub requests, but at least before the fibers implementation that was made, those would still run one after the other. So you would have different blocks on your page, and the blocks would be streamed one at a time. Mm-hmm. What they've been able to do with the BigPipe implementation is to start processing those at the same time as the sub requests, and then start adding them as soon as they're ready. So that's really kind of the waterfall that you saw before, and then squishing that in.
Cool, thank you.
If not, then I want to thank you all for coming.